This is question 7 from the CCEA Maths AS Pure paper, and this one's from May 2024. So a wee bit of applications of differentiation here. I think a single piece of wire is bent into this shape here. The wire forms the outline of 3 sides of a rectangle. We can see that surmounted by a semicircle in the top. The rectangle has width x and the length y. The wire is 8 centimeters long, and we have to show that. So the distance all the way around this then is going to be 8, and we need to find that in terms of x and y. Obviously we have a wee semicircle here, and that then would be a half x, so that would be a radius there. So remember, our circumference of a circle is 2 pi r, so we're good then with just pi r because we want half of the circle. So that means we know, let's see what we have. We're going to have this plus this, so that's going to be 2y. We're going to have this plus x, and then this is a wee bit, so we want this distance here, so it's going to be pi times the radius, which is a half x, so that's going to be pi x over 2, and we know that all adds in to give us 8. Rearranging then, because you're trying to get y on its own, 2y equals 8 minus x minus pi x over 2, dividing everything by 2, y equals 4 minus x over 2 minus pi x. Remember, to make this one twice as small, we would write then pi x over 4. Part 2 then says, hence find in terms of pi the value of x for which the area of the rectangle is a maximum. So it's the rectangle here, and they've put that in bold. So it's just this wee bit here that we're trying to find to make it a maximum. So our area, as we know, is going to be x, y. We know, so we're trying to work it out for x, and then rearranging then for a y, that's going to be 4 minus x over 2 minus pi x over 4. Do you see what I've done there? I've exchanged my y in the previous question then just for this. Multiplying this out and tidying it up. Kind of brought those wee fractions to the front. I think it's going to be easier then to differentiate, and we want to differentiate now. I always remember it's y and x is dy by dx, so here it's going to be dA by dx, and differentiate each of these terms. So differentiate that, it gives me a 4 times that, so it's just then minus x, and then times this by the 2 is minus pi over 2x. For a maximum, we're going to put dA by dx equal to 0. So 0 equals 4 minus x minus pi over 2x. This looks a wee bit complicated. We're trying to work out what x is. So I'm going to take both these x terms over here and then factorize them out. So it's going to be x plus pi over 2x, and that equals 4. X upon 1 plus pi over 2 is 4. X then is 4 over 1 plus pi over 2. We've kind of a fraction within a fraction, so I'm going to times everything top and bottom here by 2. So it's going to be 8 over 2 plus pi. And that's my answer there, fine in terms of things. So that's my value then of x. Again, you could put that into your calculator and get a value for it if you wish. We need to show it's a maximum. That's just our last bit then. So we then need to find d2a by dx squared. So let's go back up to dA by dx. Hopefully you can see it here. Differentiate that, it disappears. Differentiate the minus x, we get minus 1. Differentiate minus pi over 2x, we get minus pi over 2. So that's minus 1 minus pi over 2. That is definitely a negative number. So we know d2a by dx squared is less than 0. Therefore, it is indeed a maximum.